Welcome, I'm Jost Underhoop and with me is Oliver Franz.
Hello Jost.
The population of rotating equipment in the process industry is gigantic. Pumps, compressors and auxiliary systems are integral components of the production process. Many of these are rated as critical and call for reliable and ample machinery safety systems. These safety or protection systems are available in a variety of designs. They span from eutectic devices to SIL certified systems with diagnostic capabilities. SIL rings a bell? SIL stands for Safety Integrity Level. It is a measure of system performance or probability of failure on demand. In the nomenclature of the IAC, the Safety Protection Unit is called Safety Instrumented System, short SIS. When we talk about SIL and SIS, we also have to talk about PTI. A proof test interval is a requirement according to the IAC life cycle concept. This SIS validation has to be rolled out on a regular basis and must be conducted as defined procedures that ensure the system tests are done correctly. Properly conducted PTIs are the best and only measure to ensure the protection of your critical production assets and to manage risks. How do you validate all functions and safety concepts of the protection racks you are using? Stimulating a vibration probe with a shaker does not cut it. Dismounting and stimulating an eddy current sensor with a micrometer to make out a displacement signal will end up with a recalibration after the install of the probe. Oliver, what is the answer from PROGNOST Systems to this unsatisfying situation?
Thank you, Jost, for the introduction into the world of machinery protection, IEC, SIL, SIS and PTI. Back to your question, Jost. PROGNOST answer is a sensor simulator instead of a sensor stimulator. The PROGNOST sensor simulator, short SenSim, is a portable device for the simulation of sensors that are used for machinery monitoring. It simulates sensors with static and dynamic signals for safety protection systems and measuring loop test routines. Basically, it has two components: the SenSim handheld and the SenSim generator. The handheld is a rugged device with a touch screen. It runs the configuration software for the generator. The generator processes the configuration and produces the requested signals. Both components are connected via a USB cable. To ensure user-friendliness, the generator can be disconnected after configuration and be used as a single piece of equipment for the test routine. With the PROGNOST SenSim, it is possible to simulate all types of sensors, including their electrical behavior. That means you can simulate the full sensor range and are not limited to your stimulator or shaker capabilities. Furthermore, with this device, it is possible to simulate all different types of dynamic signals fully phased to a given trigger signal. So let's talk about the simulated sensors that we offer. So we talk about a trigger sensor to which all other dynamic signals are referenced against. We have on channel 1 and 2 the 4 to 20 milliamp, which are frequently used on pressure signals, ICP or IEPE, typically used for vibration sensors, as well as eddy current. We simulate proximity, peak to peak there, voltage, pulse, and even strain gauge simulation is possible. With this device, you can enable for a realistic testing of safety protection functions and algorithms, including even a 2 out of X voting, as we can simulate up to 3 dynamic channels in parallel. And we have a built-in, or we can also use it for plausibility checks and use it to count a number of consecutive revolutions. With the PROGNOST SenSim, you are able to simulate the damages freely with freely shapeable amplitudes and frequencies per revolution. Now, let's have a look of the PROGNOST SenSim in realistic use. Now we have connected our PROGNOST SenSim to a demo rack consisting of the PROGNOST Silver Machinery Protection and Data Acquisition Rack. analyzing the signal, and if machine conditions do change, it initiates a machine status change, which could be an alert, a shutdown, or an unsafe, indicated by its dedicated 3 relay outputs. On top, we see that in this case, this application, this protection rack monitors a 2-throw reciprocating compressor, which is safeguarded through 2 crosshead vibration sensors, acceleration sensors, ICP type in this case, and we also see the corresponding speed indication. That machine runs at 300 RPM right now, smoothly running. Currently, we monitor about 5G, 50 meter per square second of crosshead acceleration per throw. The visualization you see here on screen is shown in 36 segments. The PROGNOST way is to monitor vibration levels in 10-degree wide increments. So every 10-degree increment we have an average vibration value we indicate here. And now we will start simulating with the PROGNOST SenSim in parallel 3 parallel sensors here, which is the trigger or the speed reference, and 2 parallel ICP channels, which will allow us also to mimic and simulate a voting scheme where we can have 2 out of X voting and safety limit violations. So in the first step, I would like to change the configuration of channel number 1, which is now set to the signal type ICP, an acceleration sensor of 100 millivolt per G. It could also be different other styles. Unit is meter per square second. That could be German, UK, US. Let's stick with SI units in this case. We will now change the value from a dynamic RMS value from, say, 50 in a first go. We apply it directly, and we will see 50 meter per square second on screen. The signal, the sensor we now drive into the protection rack, is simulating 50 meter per square second. Now let's go and violate the safety limit, slowly increasing to those values that are most applicable. We will apply directly an 80 meter per square second value, which in this case does violate the safety limits visible on screen, visible in a machinery 1 safety limit violation, as well as on the relay output we see alert and shutdown are in violation. Okay, we've now found out this safety loop works effectively. Let's switch back to a moderate value, say of back to 50 meter per square second. The value has dropped down again. It'll now only take a second for the machine to recognize, for the protection rack to recognize machine number 1 is in good condition again. We can now reset the demo rack and are back in good operating condition. We could do this in parallel with 2 channels, channel 1 and 2, but let me also show you how the trigger signal is being changed. In this case, we run at 300 RPM. This is freely configurable, so you can really go full sensor range. Let's go, for example, to 3000. A very common frequency. Apply. Yes. And we will now see that we have changed it to 3000 RPM. So now we have a new simulated speed. We can also go to a value like 600. Apply configuration. Yes. And the speed is then indicated on our HMI, knowing that we are in safe condition, the machine speed is given, and the vibration signals are phased properly against this given speed.
Well, Oliver, obviously it all adds up to PROGNOST SenSim.
Absolutely, Jost.
Oliver and I hope that the last minutes have been of value for you. Have you all a good time and take care.